Hello, everyone. Today is Thursday, December 18th, and this is week 7, day 3 of India Evening and Weekend Platoon. Today, we're going to cover SQL queries, breaking down big queries. So it's just a continuation of SQL. So I'm going to do just a quick overview of what you've learned so far. So I'm just going to ask you a couple questions. What is SQL?
SQL query language.
It's a SQL query language. What's a query?
A search through a database or a search through data.
Yeah, it's kind of like a request for information. Yes? Okay. Does a query alter a database? No. Correct. What what does it do?
Retrieves the information that exists in the database.
Yeah, that's it. That's a really important thing to keep in mind here. Queries are just requests for information, and you're requesting a certain kind of information. Yes? Keep that in mind. That's really important today and for the entire SQL language. Now, ultimately, right now you are learning how to query databases, specifically relational database. In this case, Postgres, right? But just know that in the future, and this is just something to keep in mind, no one really writes out raw SQL, which is what you're learning to do right now. You're just learning this querying language because this is what's under the hood of other layers of software that you will eventually use. And these other layers of software abstract what's happening under the hood, which for a lot of them, and which you're going to learn in this class, is writing raw SQL. And even when you get to your job, they might have some software, right, that has a nice little GUI for you to build your own SQL queries, right? Make sense? Right now, you're learning basic SQL, kind of understand how you query a relational database under the hood. But ultimately, no one really writes raw SQL queries. A good example of this is CSS. We taught you how to write raw CSS, right? Yes? You know how to do that? How to change like the color of a title to red and underline it and make it italics and all that? Yeah? In the future, no one really writes raw CSS. You'll use some kind of library like Tailwind or Bootstrap or Material UI or stuff like that, which Material UI and Bootstrap you'll be introduced to in this course. But there's some really fancy stuff out there like Tailwind, very popular at the moment. That's how you'll eventually style web pages or some kind of in-house framework. Yes? Make sense? Why is it so important that you understand conceptually how things work under the hood? One, that's ultimately how you become a good problem solver in tech, in software development. But also, there are going to be times where the built-in tools that you have or the tools that you have paid for don't fit your use case perfectly. In which case, you are going to be asked to do what?
Maybe learn.
Yeah. So let me ask that question again, make sure that it's clear. You will run into situations where the out-of-the-box solutions won't solve your use case. And that will cause you to do what you think.
Think outside the box.
Kind of, but that's just vague, right? That's actually one of the very few times you're going to be asked to code something. You're going to have to develop a solution, right? One of the very few times you get a chance to code something, right? Because the out-of-the-box solution or the in-house library that you have doesn't quite fulfill the use case, or you have some odd edge cases, or you have some kind of quirky internal applications that have to use this service, right? And that integration doesn't exist because your company has very unique internal tools, right? So that's when a team will be assigned a specific application to maintain, to develop, and a lot of the time to upgrade, because within your company, they're asking for new features or they're asking for this kind of integration that doesn't work or doesn't exist yet. Does that make sense? It's difficult to do that, but you don't understand how things work under the hood. Okay, awesome. We know what SQL is. It's just a querying language. It's a request of information, and we request this information from where?
Databases.
Yeah, the database. That's it. Cool. Seems like you guys understand all that. So we will jump into the lesson. Oh, he's still waiting in the lesson, in the lobby. Give me 1 second. I don't see anything. When is he in? Yes. Sorry, I just saw this in the chat. Okay, I think they're in. Okay, cool. Let's jump in to today's lesson. Sure. Okay, you can see today's lesson, yes? SQL queries, breaking down big queries, yes?
Yep.
Alrighty, so if you haven't messed this already, you'll be executing queries against the cars database. So you need to clone this repo, right? If I open this, I already opened it, it's here. So you're gonna go in here and you're just gonna clone it. Copy this, get clone in wherever folder you wanna work from, and then clone it down, yes? You're gonna clone this cars database, right? And this is what the schema looks like, right? Doesn't make a whole lot of sense right now. That's okay. These are just the different tables that exist within this cars database. And this database is just going to have a bunch of information about what?
About cars.
Yep. Just going to have a bunch of information about cars, right? So when you clone it, you're going to have something very similar to this, right? I'm going to go ahead and actually make this smaller. You're going to have something like this. You're going to get clone and you're going to get a cars database. And you can actually look in here, right? You can look at everything if you want. This is a little schema page. This is what was in there. This is a Docker file, right? This is a init SQL. I'll admit. If you look in here, this init file, just by looking at it, what do you think is happening in here?
It's building the database.
Yeah, it's not quite building the database. That's pretty close. The words matter here. It's doing what?
Creating the database.
No. Think of your words. You're very close, but the words matter here. It's not creating the database. You're
So they're
creating
creating the tables
yes, within the
database.
database. And this last part here, line 56 to probably the end, is doing what? If you had to guess.
Filling the information into each table.
Populating the tables, right? Okay. So it kind of looks like here you're creating some kind of database, but here you're connecting to that freshly created database. Now you're creating tables, right? And then you're inserting all the data, right? So this appears to be an executable, right? How you're going to populate this cars database, right? This is a README that shows you what to do, how to start it, how to populate it, and this is some kind of script, right? And this script is just a what?
call to pull all information from.
Yeah,
car.
yeah, just a SQL query, right? Select star, select everything from the database car, right? Or from the table car. Well, let's look. If I go in here, there's a table called app user, user profile, car model, and there's your car table right there. So my cars database has how many tables? 1, 2, 3, 4, 5, 5 tables, right? And if I look at my image, those are my 5 tables, right? Yes? Cool. I've already ran through these commands, but I kind of want to walk through them a little bit. Build the image. What is this command doing?
Creates the Docker image.
What's a Docker image?
It's like a little snow globe.
I don't even know what that means.
Isn't it taking whatever's set in the Docker file and just because I was asking this question when we were doing internally. I didn't ask the instructor anything, but when we're saying build the cars database, um, is it taking what's in that Docker file and then creating a database called cars_db?
Yeah, here, right, is kind of building a blueprint for this database. So the image is just a blueprint for what you are going to build. Yes? Like if you have this blueprint, could you make a bunch of copies of it?
Yes.
Yeah, you could, right? That's what blueprint is, right? So then you're going to run the image, right? What does this command do?
So it looks like it names the image as runner, gives it an image. Because when I did a Docker PS on this, then it shows the image ID, which is like this whatever number, and then it had runner on there. And I only know that because I had to like remove it because I kept messing it up. I don't know what I was doing wrong, but eventually I got it. But I remember it was I could take and just remove runner, and so that which was the image, like an alias of the image or something like that.
Yeah, but I just asked what this command does. And then someone tell me what this command does, and then we'll break it down word for word.
Creating an instance of that image.
Yeah, but that's kind of vague. You're creating what exactly? All right, let's go from the top. This just builds a blueprint of this database, right? And it's going to build it based on this Docker file. Whatever's in here, this is a really simple Docker file. But if this was really long, it still built that specific blueprint, right? So you build a blueprint. Here it launches a what?
The container.
Yeah, it launches the container. Hey, launch a container, name it runner. This RM is really not that important. It just means, hey, remove the container if the container ever stops, right? And then it says, hey, set the default password to password, right? Create a database within the container called carsDB. If you don't understand what all those flags mean, that's okay. I forget what some of those flags mean. I forget what the E means, honestly. Forgot what it means. That's okay. You just have to have a general idea of what the commands do. And a good exercise is while you're going through this, right, make sure you understand exactly what this command is doing and what these flags mean. That's going to help you kind of understand what you're trying to accomplish. Make sense? Break it down. Make sure you understand what that means, right? So execute a query, Docker PS, and I can run it in here. Let me pull it up. I can say Docker PS. Docker PS is going to show me what?
All running containers.
Yeah, all running containers. And it's going to show me this very cool thing called a container ID, which just identifies. I could have Can I have 100 containers running on my computer? Of course.
If it can handle it.
Yeah, if I have the hardware to run 100 containers locally, I can, right? I'm actually only limited by how much power my computer has, right? So you could. I only have one, and remember the names are runner. I could have named that anything. That's not a special word or anything, right? So this just tells me, hey, what containers are running in my machine, right? And then this command does what? I have the container ID. I have it right here. What's this container telling me to do?
You're executing that container, the one that you pull up before that one.
Yeah, but that doesn't. You're not really answering my question. What is that? What does this command do? It does what?
That's what I'm
Starts the
guessing.
container.
It does what?
Starts the container.
No, it already started, right? Docker run starts the container based on that image that you just created.
Or maybe you go inside of the container now.
Yes, that's really important, Jose. Nice job. You're going inside of this container, right? And you're opening a terminal on it. That's really important. I already have this command saved in here because I was messing with it last night. So I am going to Docker exec IT means, hey, open a terminal inside of this Docker container, this one right here. Notice how the IDs match, and open a bash shell. Yes? Okay, I'm about to do it. And I'm going to open another terminal. Are these two environments the same? This is one terminal, this is two terminals. Are these two environments the same?
Let's say no, because I was messing something up last week, and there's commands I was trying to run within the container, and I had to get out of the container and run it on the host database. And so, or maybe, so I think it's different because of that.
Okay. Your explanation's wonky, but you do have the right answer. These are two completely different environments. What environment is this one, the one on the right? This one?
That's the database environment. They call it
No,
database.
no.
It's just your regular directory that you're in on your computer.
Yes.
Gotcha.
This is just a regular directory. I happen to be inside of CAR's database, right? But this terminal is local to my machine, right?
Gotcha.
Now, remember, what are the two tenets of Linux? This becomes really important for this lesson, and actually for all lessons going forward.
Is it
What
who
was
I
the
am
question?
and where I am?
Yes, who I am and where I am. That's going to become really important here, okay? Because we're about to do some inception shit here in a second. Okay. The shell on my right is a bash shell. It's a Mac, so they call it a ZSA shell. It's just a fancy bash shell, but it's just a bash shell, right? So if I say, echo hello, what do you see? Echo hello, right? Can I do that on the left? What am I trying to illustrate here? Both of them are bash shells, but one of them is local to my machine, and the one on the left, this is local to what?
The Docker container?
Yes. Super, super important. Understanding where you are here, right? I guarantee you, and we have it every cohort, right? When you start loading your APIs and containers and you Dockerizing your application and then you start sending it to AWS, right? There's a misunderstanding of the environments that you're working in. You're running commands and shells that don't take those commands, and you're wondering why it's not working. right? You're trying to connect one container to another, right? And the ports are different, so they can't talk to each other, right? Very common mistakes that happen here shortly. I'm trying to emphasize the difference of these environments, right? So these two environments, despite the fact that they're both bash shells, are different. One is local to my machine, and the minute that I go into that Docker container, it's a completely different environment. Yes? Okay. So I was here, but then I started up a Docker container and I said, hey, open a terminal. And this acts just like a regular bash terminal because that's what it is, right? So if I clear, it's going to do the same one, the same thing. Notice that I just cleared both of them and they did the exact same thing, right? Okay, cool. But on the left, I'm inside my Docker container. Okay, so that's really important. All right, so let's go to the next command here. What is this command doing? You don't have to tell me word for word what it does, but just generally, what does this command do?
Does it connect the Docker to the Postgres?
Kind of. I think you're saying it kind of funky, but it connects to the Postgres in the Docker.
Okay, yeah.
Okay, so we take that command, right? So let's grab it, right? Let's take the command, right? We're not going to break it down word for word, but it's just saying, hey, open up a command line tool inside of my database, inside my Postgres database, right? The fact that it's in a Docker container is kind of irrelevant here. All right, so I run that command. Oh, sorry. Nisha's here. Okay, here we go. So I run that. And where am I now? On my left. Where am I here?
In the cars database?
I am inside the cars database that is inside a Docker container that is on my machine. How many different environments are those?
Three?
Yes. Are those three environments the same?
No.
Correct. They're not. One of them is a terminal for my database. One of them is a bash shell within a Docker container. And then the other one's my computer. So where you are here becomes incredibly important. And I'm going to push this one step further. I could deploy these Docker containers to AWS. Is the AWS environment, and I just gave AWS, but you could deploy it to Google or Azure or whatever, Oracle, right? Is the AWS or Oracle or Azure environment different than the other three environments that I just mentioned?
Yeah.
Okay. If I push this API or whatever it is that I'm creating here in a Docker container and I send it to AWS, now you have a database inside a Docker container on AWS. That's different than being a database in a container on my machine, right? Those are different. Two tenants in Linux. Where are you? Who are you? And where are you? It's become pivotal. Make sense? I hope I didn't lose too many people. And I want to just spend time on that because that's like the cause of a lot of problems when we're learning this. People really struggle with that concept, right? It's a little like Inception. Everyone understand that? Any questions about that for right now? I know this is a little hard to follow, but that's actually really important.
Just a dude playing a dude disguised as another dude.
Pretty much, yeah, just like that. All right, let's go. So we're going to go with this cars database here, right? I know by looking at my code, if I look at init here, I know that there's a table called car model. Can I grab everything from car model? Yeah. Let's just select what? This work? All right, gives me all of my car models. Cool. I can press enter and it can go all the way down. Cool, cool, cool. I actually didn't know there was that many models of car. I can just press Q and I can come out. And I am currently in my terminal in my database. How do I back out of my database, out off my database? I press what?
That's key.
It's \D, right? Is that what it is? Yes. Oh, wasn't quite that. What is it? How do I exit my database here?
/Q.
What is it?
/Q.
\Q, like this? It wasn't D, it's \Q. Yes?
Yes.
Okay. \Q because I'm inside PSQL terminal. And I know that that command was right because what do you see now?
Container terminal.
Which terminal?
The container.
Yeah, I'm in the bash terminal of my container. So here, all my bash commands work, right? So if I wanted to exit this, I could just do exit. And I'm back where?
Your host terminal.
In my machine, right? Now, these two locations are identical, yes? Excellent. All right, cool. So we know that this works, and these are the commands. Don't do this. This is a faster way to do this, and eventually we'll teach you how to write a little bit of bash scripting to automate a lot of this stuff. This is very manual. I kind of would encourage you to just do it this way for right now. Can anyone tell me why I'm encouraging you to do it this way for right now?
Just muscle memory.
Yeah, it's muscle memory. And that exercise that we just went through for the last 20 minutes, I want you to keep in mind. Be very cognizant of where you are and what commands you're punching in and what they're doing, right? Eventually, this is kind of a fast way to do it. There's a little more to that, but eventually you're just going to write a bash script that's going to just do everything for you. But right now, that's an abstraction, and I want you to focus on abstraction. I want you to do it the long way for right now. Make sense? Cool. Alrighty. So you loaded up everything, right? We're going to be using the cars database. I just showed you, we just went into it and I just ran a select star command to show you, hey, my data is populated. So let's go back to the main lesson here. SQL queries breaking down big queries. It can be tough to parse or break down requirements for a complex SQL query. Here are some general steps you can follow. First step, figure out which tables you need to answer the question. Super important. Figure out which tables you need to answer the question. Right now, you only have 5, and frankly, your personal projects and group projects won't really have more than that. Maybe one more, but not many. Maybe even less. But sometimes, if you're working on a big production application, you're going to have a bunch, right? Let me give you kind of an example. I don't know if this is too much of a stretch, but I know I use Netflix as an example a lot, but think about Netflix. What kind of tables do you think Netflix, this is just kind of an exercise. What kind of tables do you think Netflix has?
The genre.
Genre table, maybe. What else?
User profile, for sure.
User profile table. What else? Come on, you can think of more than this. Let's just try to think of 7 or 8.
All right. Yeah.
What else?
So
Recently viewed.
Recently viewed could be a table. Yeah. What else? User information, right? Maybe credit card information or payment info. right? Yes? It probably has a countries table somewhere. Can anyone tell me why? I don't know if anyone knows this. Or has, if you've watched Netflix in different countries, you probably know where I'm aiming for. Is the content
Some,
different based on countries?
Yeah,
Yeah,
this-
movie.
Yeah, it's licensing of content, right? One time I was in Mexico and I was watching Rick and Morty, but at the time, and I don't even know if this is true today. I don't think so. Rick and Morty is not an American Netflix, but it is available in Mexico Netflix, right? So that has to do with licensing of content. I don't really know how that works, but I know it is different, right? And what is popular in Netflix in America is probably slightly different. I know what's popular in Colombia or Japan or something like that, right? All right. So those are just some examples of just an application that would have tons and tons of tables, right? But this, we're just dealing with 5. All right. So figure out which tables you need to answer the question. Figure out how to connect the tables together if necessary. When it says connect the tables together, you're going to connect them through what typically?
Join.
Yeah, through joins, through primary keys, but are you actually joining the tables together? Join is a little bit of a misnomer, right? Because you're not joining tables together. What are you actually doing?
joining the outputs together.
Yeah, you said it kind of awkwardly, right? But you're fetching a little bit of information from this table, a little bit of information from that table, a little bit of information from that other table, and a little bit of information on that other table. The tables in your database never come together, right? The answer is they don't. They stay as is. The query just grabs the information from a multitude of different tables and then shows it to you. Yes? Okay, conceptually super important. Cool. All right, write a query getting all the columns with some limits, right? This limit is really important because it does what?
Limits how many rows appear on the screen so it doesn't flood it
Yes.
or run
Yes.
forever.
Yep, exactly. Bullet point number 3 is actually one of the biggest tips that I have for you. When you're building a query, you should always have a limit. You should have a limit to like 2 or even 1. Why do I say that? You kind of already answered it, Nicholas, but let's say it again.
To keep it from flooding your screen or just running
Yeah,
forever.
yeah. And if if your query is wrong, you don't want it to take time to populate all that, right? And you have to scroll through it and exit and do it again, right? So you have 2 options here. If you've already preloaded the data or you know that the tables have a lot of data, you should always set a limit on your query, always, right? Or if you're populating the database, right, just always include 1 or 2 data points, right? Yes? Let me give you an example here. This lesson was poorly done because you guys are beginners and they populated way too much what?
Data.
Too much data. Yeah. You could have taught this exact same lesson with 3 of these or 4 of these because you're learning these big, long queries, right? We need to focus on learning the queries, right? Not being overwhelmed by the output, right? And this is going to happen to all of you, right? When you start building out your backends and populating your databases, one of the most common mistakes that I see is you populate it with too much information. Populate it with 1 and make sure your application works with 1. And if your entire data flow in your application works with 1, you can start putting more data, right? Same thing when you start building these to-do lists. Have we covered CRUD yet?
It was mentioned, but it was mentioned lightly.
Create is CRUD is pretty much what all your applications do, right? You create, you read, you update, and delete. They're kind of like routes, right? When you let's use Facebook as an example. When you create a new post, you create, right? When you read someone's message or their status update, you read it, right? When you make a typo on the post that you made, there's a little edit button, right? And you go in there and you change it. That's update. And then when your post doesn't get that many likes, right? You delete it. So the four basic functions of managing data in applications and databases. Those are your four. Eventually, they're going to cover it in greater detail, but this is kind of an important thing to understand right now. And SQL queries only use one of these. Which one?
Read.
Yes, because we don't alter databases with queries. We just request the information that we want. Yes? Cool. Alrighty. Always set a limit unless the data that you have is really small, for the reasons we've mentioned. And the last one, filter, aggregate, one step at a time, right? Just like you would write anything, just one step at a time, right? Filter, aggregate, one step at a time. Let's walk through this using fairly complex example. This example is a little too complex, but we're going to try to make the best of it here. All right. Question. I want to get the total number of each make advertised in each city ordered by city. Let's try to pseudocode this. I know this is kind of weird, but we're going to try. We're going to pseudocode this. That's my question right there. I want to get the total number of each advertised in each city ordered by city. How would you start trying to build this query?
Probably by thinking of what the output should be.
Not quite. You need to break this down. This is asking for a lot, right? Is asking for,
Account.
yeah, total is a count. So it's an aggregation. So it's asking of an aggregation of each make, right? Like 50 Toyotas, 50 Cadillacs, 100 Lexuses, whatever, right? It's asking for an aggregation of the makes in each of the cities in the database ordered by city. Now, this is a little vague, ordered by city, like ordered by city in alphabetical order or ordered by number. I don't know, but that's okay. Let's try to, how would you start writing this query? What's the first kind of part? What's the first kind of query you would try to write?
Select from city, from advertisement inner join, something like that.
Yeah, but you're trying to tackle it all together. That's hard, man.
I'm just doing my best.
No. But that's why I'm trying to teach you this. Like, you really wouldn't start at the, I don't even know how to do that. Like, I forgot, right? I forgot how to do that. I don't really know. Again, I told you no one really writes raw SQL, right? I forgot how to do it. But I can walk you through how I would build this. You want me to walk you through and then you can kind of see how?
Good to go.
Yes?
Yep.
I don't even remember the syntax, but I can give you the pseudocode for it. All right. It says, I want to get the total of each make advertised in each city ordered by city. Which part of this do you think would be the easiest to tackle first?
Probably the total number in each city.
Total
There's
number of what?
total number of cars. Oh, I mean,
Yeah.
total number of makes. Okay.
Okay, how would you do that?
You select like select make from. Yeah, look at this.
How about in plain English? Just in plain English. I don't
Oh,
even want you to write the syntax.
okay. I just select the make from city.
And now you're doing exactly what I'm asking you not to do. You're trying to actually write the query. I just want it in English. How would you break this down?
Just get the total number of each make of car. So just get the total number of each one, and then get the
Ah,
total
you're
number.
you're building it. It's too hard. Look what you're saying. You're trying to already get a total. That's an aggregation, and then you're trying to get it by make. You're doing too much there.
Okay.
All right, let me walk you through this. Eventually, you are going to figure out how to do it and build the entire query, right? But the way that I look at this, well, even remembering how to actually write SQL, right? It would be, I would look for what? Look for every car what?
Make.
Close, advertised. You could do it with make, right? The order that I'm going to give you is not the be all end all. I'm just going to tell you how I think about it, right? So I'm going to look for every car that's advertised. What they don't tell you here is that some cars that are in the database, it's possible that they're not advertised, right? So I don't care about those, right? I don't care about cars in the database that aren't advertised. So I'm going to look for every car that's advertised, right? Then I am going to, for each ad, right? A car only has an ad if it's advertised, yes? All right, so for each ad, what do I have to keep, kind of keep mind of?
What city it was in and how many have been
No,
done
you're
in that
jumping
city.
ahead. You're jumping ahead. The city was right, but I'm not trying to aggregate. That's at the end. City and what? The thing that I'm
Oh,
aggregating
the
though.
make.
There you go. Boom. Right? Then I'm going to do what? Now here comes kind of the little bit of the aggregation.
Sort.
Now, oh, kind of, right? All right, so let's look conceptually here. This is just English. I'm not even writing C because honestly, I don't know how to write it. I forgot. All right, so I want to get a total number of each make advertised in each city ordered by city. First, I'm going to look for every card that's advertised, right? Every card that's advertised, cool. I'm going to look at that advertisement. For each ad, know two things, the city and the make. Then I'm going to do what? Put the ads together that share what?
The make in the city.
Make and city, yeah. Make and city. And then now here comes the aggregation. I'm going to count what?
How many ads were done for that make in each city?
And the last thing,
Sort by city.
yeah, or just show results by city because the city, the makes are then are going to be aggregated together, right? They're going to be shown together. So show results by city. I'm going to drop this in the chat. Actually, I dropped it later. That's kind of how you should be breaking it down. What's the common mistake that everyone was making right at the beginning of this? Outside of like trying to write it in actually SQL from the beginning. They were doing what? Hey, if you could think about it in SQL terms right off the bat, off the dome, bless you. You're better than I. You're better than many of us. And that's totally fine. If you can do that right off the jump, congratulations. Very few people can do that. I can't do that. So I'm teaching you this way. It's going to be much easier for most of you. Right? What's the biggest mistake you guys were making when we're doing this? You're doing what?
Too
Kind
many
of,
steps at one time.
yes. Yes, and that's a super common problem for beginning programmers. You try to do too much at once. That's not how programming works. You have to kind of teach yourself, right, to kind of go back down to basics, right, to really break a problem down in its core components. Try to do as few steps at once as possible until you build out the entire query. Just do, if you can, one thing at a time. I'm not quite sure if I mentioned this, right? Or if anyone else has mentioned this, but in programming, every function should have how many responsibilities? I don't know if anyone's taught you this yet. In programming, every function should only have how many responsibilities? How many things that it does?
One
One.
thing
Yeah.
at a time.
Yeah, just one.
Concern.
There is hardly any exception to that rule. In real programming, all functions just do one thing. That's it. And they're always agnostic and nothing's ever hard coded. And any parameters that they need are done what to it? There.
Given to it. Input.
Yeah, they're passed to it, but yes, Logan. Same thing here. When you're building a query, you want to do just one thing at a time. Notice what I did. I looked for every car that's advertised. That's just one thing. For each advertisement, I just noted, hey, what's the city and the make? I could have, here's the thing. Look at two. I could have gone in here, right? I could have done note make, note city, and then my step 3 could have been them together, and then gone on to step 5, 6, and 7. I could have made that more steps if mentally I needed to do that, and that's totally fine. I did them together because that's how I was, and it seemed like not that big of a deal, right? But if you needed to see the city first, and then the make, and then do city and make in your next SQL query, you could have easily done that as well. It would have been more steps, and it would have been more broken down, but it would have got you there just the same. All right, cool. First, we need to figure out, and then the only last thing you need to do, I just gave you plain English. You convert this to what?
And the same text we're looking for freaking what's the name of that? SQL.
What's up?
You saying you convert that to what? Right?
You convert that to what?
To the SQL syntax you're looking for? Select from whatever.
Yes. Let's do that exercise, actually. Give me 1 second. Did I let everybody in? Sorry. I don't know if I'm terrible with Zoom. This looks right. Everyone looks in. Yeah. Okay. Sorry. I was a little late on a couple of you guys. All right. This is what we're going to do. I just rambled for way too long. So this is what's going to happen. I am going to post this pseudocode because that's all it is. And well, I'm going to post it right now. And then we're going to go on break. We're going to take a 20-minute break. We're going to come back at 6:42. And at 6:42, you guys are going to work on that. I'm not even going to open breakout rooms from right now. You're going to work on it individually and line by line, write that SQL statement line by line. So you should have 5 SQL statements. How you built it piece by piece. Yes? Make sense? All right, 20-minute break, come back at 6:42. And at 6:42, we're just going to jump in this room, work on that exercise for right now, and then we'll move on. All right, guys, that was like 21 minutes. How do we do? Anyone? It's okay if you didn't get very far. Who got the furthest? I don't know what I'll do. Thought I wrote right. Yeah, I did. Okay. I'll go ahead and drop the answer in the chat, and we can kind of walk through it. I'm going to drop my answer. Actually, this is good. There's the README answer, and then there's my answer. It's a little different. I'll post it just in the thread. Yeah, just posted it in the chat. All right. Sorry, I lost you guys. Okay. How far did we get before we start looking at the assignment? You guys hear me? No one's saying anything. Okay, Nicholas.
We can hear you.
Just made it to be able to sort them by city and make. Okay, that's pretty good. Anyone else?
I think I spent the first 10 minutes realizing how hard the question actually was to answer before I realized like what I should be doing.
Yeah, that's totally normal. That makes sense. Let's walk through my answer and then we'll go over the repo answer very quickly. And then you can just read the README later if you still have questions on that one. Let's look at it. We're just going to go over the answer that I just went over. These are really long queries. And eventually we develop software that does this for us. And we develop little GUIs that help us. So you don't have to write raw SQL into a database, right? All right. All right. Can you see my screen? Okay. Let's look at the 5 steps that I gave you and then kind of walk through each of them. This is a little bit different than what the README has, but that's okay. I actually didn't look at the README. I just did it myself because I was kind of giving you the notes on the fly there. All right, so let's look at it. This is exactly what we had. The question was, hey, I wanted to get the total number of each make advertised in each city, ordered by city. Okay, cool. I've wrote 5 little steps. Let's look at the SQL query by step. Step 1, look for every car advertised. The SQL equivalent would be from advertisement A. What is A in line 4?
Like a variable name that you're setting it to?
It's an alias. So A means what?
Advertisement.
Yes, super important. What this is saying is, hey, from the table advertisement, how do I know which tables I have? Just go to either you can go to your schema or you can go to here. And now you have an advertisement table, right? From table name, classic search. Yes, thumbs up. All right, so let's look at text from advertisement, and I'm just going to do A for advertisement. Easy enough? Yes? Cool. For each For each advertisement. Note two things, city and make. And this is where your joins come in. Join user profile up on a seller account ID equals up account ID. See if I can pull this up actually. Actually, before I do that, what two tables am I looking at on line 6? Or attempting to join? What two tables?
User profile and advertisement.
How do you know that, Nicholas?
Because you're joining the user profile, which you're then given an alias at the same time on A, which is advertisement dot seller account ID to equal the user profile dot account ID.
Correct. That was perfect, Nicholas. Nice job. Here, this A, guys, I didn't want to give them aliases. And actually, even if you kind of did, you could write the whole word advertise. You guys are going to already figure out that I can't spell. And this could be user profile. You do not have to give them aliases. Why do people give them aliases, you think?
Faster.
Yep, that's it. Convenience. Nothing more to it. Right? Line 4, can I do from advertisement donkey? Can I do line 4? Yeah, I can give it whatever alias I want. That wouldn't make any sense at all, but I could do it. Nothing stops me from doing it, right? They typically give a short alias, right? Because it just makes it easier to write the rest of your query. That's it. Nothing more to it. All right, so here, you nailed it, Nicholas. Now here, I'm joining which two tables?
Car and car ID.
Nope. Let's try that again. Listen to my question. It was identical almost to my previous question that Nicholas answered. What two tables am I joining on line 7?
Car and advertisement ID.
Yes. No. No. You almost had it. Once again, line 7. What two tables am I joining?
Car ID.
You're not answering my question. I want you to answer my question. What two tables am I joining? Car ID is not a table.
I had to look at the table names. Car and advertiser.
Yeah, advertisement. Go ahead and go look at the schema or go look at the init file, right? You're linking car table and advertisement table, right? What is car ID? It's not a table, it's the
Column within the car's ID. For the car
yes,
ID.
it is a column, but it's really the primary key within the car table, right? That's how you identify all the cars. They all have a unique primary key. Yes, and that's how you link the tables via primary key, right? That's how you link all of the tables, right? So that's always going to be how you join them or reference them. All right. What two tables am I joining on line 8?
So I have a question on that. So when we are, and maybe it'll explain later on down the road, on the pseudo, but when we join those two tables, I guess that's what I was having issues. Um, does every category, how do the categories come together? Usually, so we're saying that, let's say line, let's look at, let's say line 7. We have advertisement, the car ID under advertisement equals the car ID under, is it a car? I think, right? Yeah, under car data. And so it joins, so this is a joiner, so it joins the two tables. So does that mean those two tables now have the two IDs are similar or one and the same now? So like let's say for instance here we're saying Jose is Guillermo and Guillermo is Jose. They're a one in the spirit now. So no matter which one you mention, all the other entities that are in the table are referenced. I guess that's the concept I'm trying to put together is now that those two IDs on those two tables equal out to each other, does every category or how does what exactly is joining? Is it all the other categories like car model ID, number of owners, and then make a model or not make a model, but advertising, and then advertisement date, seller account ID, all that stuff. All those rows are falling under all in one table now. I guess is what I'm trying to ask. Like, what is exactly being joined?
Can anyone answer that question by chance? If you can't, that's okay. I'll try to answer it to the best of my ability.
The data in each table is already identical. So you're joining it at that point so that it lines up and links it together on that same information so that it is like the car ID and the advertisement table is the same as the car ID on the cars table. So you can only link the tables at a point where the data is exactly the same.
That makes sense. Okay, so if one doesn't exist in the other, then it doesn't join.
Yes, it could be named something else in the other table, though. Just in this case, it happens to be the same exact name in each table, but the data has to be the same unique identifier.
When it comes to like in this instance, the IDs, car ID.
Car ID is car ID. No matter which table it's on, it is essentially the car ID, at least in this example of tables that we have.
Okay. And so that makes sense on what, right? But as far as the why, so that actually makes sense on what. But the why, if why do I need to join those two if those two IDs are the same in each table?
Because you're joining the tables to get the information, because now the tables themselves are linked together from that point, and then the information is now able to be pulled for that same car ID that's not on the other table. So, like in this line 7, car does not have like advertisement date in there. So then you're able to grab the advertisement date essentially in the new table that you've created for yourself, but it's only created in that instance that you've ran that query.
All right, I get it.
So you're
I get
joining to
it.
make one giant table.
Yeah, it's
Or
like
limiting it down to a small of whatever columns you need in your table to get
yeah,
whatever information.
that makes sense. Okay, so with those powers combined,
Yes.
more knowledge, more knowledge, more power. Okay, gotcha. Okay, thank you.
Guillermo, can you explain me the part about you see that table which says one too many? I'm trying to understand that because I'm pretty sure because you got two tables, right? You got two tables and
What are you referencing right now?
the one too many, the line. You see the line? So you choose one of the table. I think Jose was talking about
I
it.
don't know what you're referencing.
Uh, you see the little line that's connecting the both tables?
No idea.
uh, the connection between those two tables. Let's say app user with advertisement. there's a little line on the left, and there are like three lines on the bottom of the advertisement. See that? I'm
On
just
this
trying.
picture,
Yeah, in the picture.
oh, I see the lines, but what about the lines?
What I'm trying to figure out is, since you're joining two tables, right? You're calling the primary key of only one of the tables. How do you pick the primary key? Why is not the other primary key? Why it should be only one primary key on the left? It's because of the one too many, or I'm just trying to
I
figure
don't
out.
know where you're getting the one to many yet. That is a relationship of tables, yes. But I don't know where you're getting that from. The screen that you're seeing, I don't see that anywhere.
The if you're looking at the ERD, the lines that go back and forth between the tables, if you see more than one line at the end, that's a many relationship. And if you
Oh,
see a single,
these little
yeah,
branches?
yeah. So
Okay.
that's one to one, or well, that's car model to car is one to many, and then from car to advertisement is one to many. I don't see a many to many, but yeah.
Okay. All right. So ask me your question. I don't really understand what you're asking.
So if you go back to for example, A car ID equal to C car ID, you choose car ID because it starts with one, right? So car ID,
No, no, you don't choose it because it starts with one. You choose it because that's what you need.
okay,
Depends what the question is.
We're choosing it because the uh
because
the
one car
values
will
are the
have
same.
because one car will have
No,
many advertisements.
no. Car typically only has one advertisement, but someone can advertise many cars. It just depends what you're asking.
In this case, say that again. So we have one car, many advertisements, or one advertisements for many cars. Is that what you mean?
I don't know what your question is.
It's all right. I'll figure out. I think I'm lost. No worries.
Can anyone clarify his question or help me understand it?
So let's say we're looking at a given value for car ID and car ID and advertisement, and the value is seven. It would be seven in car ID and it would be seven in advertisement as well. Or it would be seven in car.car ID and in advertisement.car ID it would also be seven. So that's how you join the tables because both those values are seven.
Yes, but the car ID in your entire schema of tables won't be different depending on the table. It'll always be the same. That's how you link the tables. That's the
Yes,
relationship.
yes. I think that's what he's asking.
Okay. But the car ID number is irrelevant. It just matters that it's a primary key and it's the same across the tables. Does that make sense? Okay. Uh, if you're curious of how the tables are created, here, the table app user, the account ID will be the primary key, right? Your primary key is whatever relationship that table has to the other tables will always go through what? What attribute?
The primary key.
The primary key, right? The primary key of that table is how you're able to reference the relationship it has to other tables. And notice every single table will always have a what? Serial primary key that is unique to that specific table only, no duplicates, because then you mess up the relationships. So that's how you reference them. They're like a pointer, if you know what that is, right? If we go here, let me pull that up. If we look at your schema, right, and we look at the advertisement for the car ID, right, you obviously can't put the entire car table in here, right? So what do you put? You put a reference, right, to the table that holds all that information. And these are just references to other tables that illustrates that relationship. I know it's kind of hard to understand, but that's how it works. Does that make sense at least? The main thing, if you only understood one thing, understand that every single table will have a primary key and its relationship to other tables, right? We'll go through that primary key. Does that make sense? Yes?
It makes sense to me, but if we take a look, if we take a look at the two tables, car and advertisement, if the primary key is unique, which for advertisement ID and car ID, it seems to be a primary key. Now, if the primary key is unique to that table, you what we're saying is you could have it as, what would you call it? If it's not the primary key,
It's just
then what
another
is
attribute.
okay. So it could be, I guess that's the question I was gonna say. What is it then if it's seen on the advertisement table? It's just an attribute. So
Yeah,
it can be, gotcha. So then
it
it could be
doesn't,
an attribute on other tables, but it can only be a primary key on one table.
tables can have many attributes and they'll always have a primary key if they have a relationship with another table.
Gotcha.
If you look at your here, right? What do you notice about line 40? How about let's compare line 40 to line 42? What's the difference between line 40 and line 42?
Because in
Reference.
yeah,
One is an
reference.
attribute and the other one is a foreign key. Foreign key.
Not quite, just more generally. I'm not too worried about the wording here, just conceptually. What does this tell you? If I tell
Reference
you,
car model.
say that again, Yi?
The reference car model on line 42.
So tell me the difference then in one sentence. What's the difference between line 40 and line 42?
It's just a relationship. It points to
Be
a
specific. Line
specific
42 does
car.
what?
Line 42 is pointing to a specific car table, I guess.
Car model table.
Car model table, yeah.
Yes. Right. And it identifies what specific car model by passing in the car model ID. This, you can tell that there's a relationship of this table to the car models table because just by looking at the schema, right, I know that this is more or less a pointer, a reference to car model table. This manufacture year, there is no table called manufacture year. There is no reference. It is an attribute solely for this table. That is some kind of column value. There's no other table that it's joined or has a relationship on that specific value. And you can look at all of these, right? If I look at app user, right, what do we notice about app user?
There's no reference.
Yeah, app user, there's no relationship necessarily to any other table, right? Another table can reference app user via account ID, right? But there's no direct relationship. Here, there's a relationship. The app user. Here, there's a relationship to the car model table. And here, there's a relationship in advertising, the app user. Go back and just look at this. If when I look at this, honestly, I never look at this. This confuses me. If you know how to read this, awesome. I understand roughly the relationship, but typically I just go here. And this tells me everything I need to know. These are the tables and their primary keys. And there's, I don't even know. I think this is called an attribute. I don't even remember. That's what I call it. Right. I just go in here and I see, okay, this table, it has all this information. Right. Let's look at line 47 to 52. Let's look at this right here. If I just ask you a simple question here, how do I find who wrote an advertisement? By just looking at this table, just looking at these 5 lines. How do I find who wrote an advertisement?
Line 51
It tells us what, Nicholas?
tells you the app user's account ID, which is also in reference to the seller account ID in the advertisement table.
Perfect. That is perfect. If I just look at this little create table code, I know that when they look at advertisement, there's going to be a seller account ID there, right? That's going to reference some table called app user. And if I know the account ID, that's going to tell me who wrote this advertisement. And I know that by just looking at it.
But wait, you will know by the ID number.
Yeah. Yeah.
Okay.
I know by looking at just this code, right? I know, like, if I didn't see any of this other code and you just showed me this, you just showed me this and said, hey, how do I find the name? How do I find the name of the person that wrote an advertisement for a car? I would know, okay, if I look at the advertisement table, right, I know that there's going to be a seller account ID. And if I go to app user table and match that account ID, I bet in there it has their first and last name.
Okay.
Right now, you're going to do a lot of select star statements and looking at your database, right? But ultimately, you can just look, right, at your models, at your tables, right, and kind of just see what you need. This tells you a lot of information, right? What columns are in a car model table?
What do you mean what columns? You got 3 columns, right? Car model ID, make, and model, right?
Yeah. And we know something about make and model. What do we know about it? Now, within this table, what is true?
They're unique.
Yes. See, that told you a lot of information, right? I don't have to select star anything. I can just know, okay, this is kind of what that table is going to look like. Okay, this is what this table is going to look like. Cool. But that won't come. All right. Sorry, guys. That took longer than expected, but that's okay. Hopefully, we cleared things up at least a little bit. All right. So here, join. The last one is you're joining which 2 tables? Line 8?
Car model and car.
Yep. And I know that because C is the alias for the car table, and then this car model, they gave it the alias of CM, and we join them here. Line 3, put the ads together that share the city, group by, right? Group by up. What is up? What is up here?
User profile.
Yep, user profile. I know because of the alias here, right? And then CM we know is car model, right? We can do the comma in SQL, right? How many ads are in each of the groups? Here's just an aggregation. Select up city make model count star count everything as total ads. As total ads. I think when you look at the README, it has counts or something like that. That's fine. You could have called this anything, right? Total ads. Could have been anything, as, whatever. And then show results, and that's it, order by hub city, right? So here's your final query. What's the only unique thing that I didn't really cover? It's line 23. I added a what to it?
A limit.
Yeah, I just added a limit because I didn't need all that. So you go in there, punch it in. There you go. Gives you what you need. I think I gave total ads, but I think in the README it says counts or something. It doesn't really matter. You can give it whatever. I could actually go in here, and instead of, where did I make that? As total ads, I can do counts. I think that's what the README shows. Do the same thing. And what did you do to my column name? Just changed, right? It just changed it for the benefit of who?
The user.
Yeah, just the developer, really. Just me, right? Your end user, right, never gets to see any of this, right? They just interact with a GUI. Alrighty. All right, so this is what we did. We did this. These are the relations. First, we need to figure out which tables we need. We talked about the 5 tables. This is why it's so handy to have a visual representation of your tables. If you could take time to diagram it out, you'll save yourself a lot of frustration later. Some people get pretty good at diagramming it out. I am not one of those people, but if this helps you, by all means, definitely do it. These are some free diagramming modeling resources. I'm gonna be honest with you, I've never seen anyone diagram a database really, but I think people do it. If this helps you, definitely go for it. All right, so this is the important part. Hopefully this helps a little bit more. Figure out how to connect these tables together if necessary. We need the city from the user profile table and the make from the car model table. Since the user profile and the car model tables are not connected, we'll have to trace the path that connects them, right? So user profile to app user to advertisement to car model make, right? What is this tracing trying to teach you?
Relations,
The what?
relations, like the relationship.
Yeah, the relationships between the tables, right? And how do you go from one table to the next to get what you need, right? Does that make sense? Look at the top left and the bottom right. From user profile, we can grab the city where something is, right? Notice all the other tables, they don't have city, right? Only user profile has city, right? Because typically if someone's selling something, they're selling it where they live, right? So this is where you grab it. But in order to grab the make, of the cars that are being advertised, right? You have to find the relationship to all the tables to grab the make. And that's what it's trying to show you here, right?
So knowing that relationship, when you do the inner joins, do you have to do it in order or it doesn't matter?
The order matters.
Okay, so if I'm going from app user to cat model to cart model, I have to do the inner joins, orderly, uh, through advertisement, through car, and then through cart model.
Yes,
Okay.
that's actually a really good question. Can anyone tell me why can't you go from app user to car model?
There's no direct relationship between those two.
That's the answer. There is no direct relationship between app user and car model. You can look at this diagram, you can write it out, or what is it that we just said? There is no relationship from app user to car model. What is this? Is it backward D? I don't remember. How do I get out of this? That doesn't matter. I'll shrink it. So let's look back here. There is no direct relationship between app user and car model. Let's look at app user. Where's car model here? A reference to it. There isn't, right? There isn't a relationship?
Nope.
There isn't. Got to jump around. Got to find the relationship until you get there, right? There's typically never going to be, unless it's a really esoteric case, any tables just floating by themselves, right? They're all typically going to have a relationship. Unless it's some like weird edge case. Does that make sense?
Can I take a look at the table again one more time, please?
This one?
Yeah. Where is the advertisement? Since it shows that there's a relationship. I'm just asking.
Where's
It's
the
showing which
relationship?
primary keys link up by the lines, not so
Yeah.
much a specific relationship. That's where the diagram gets a little confusing comparing it to the code itself.
Yeah. So you asked a really good question, right? I knew that what you really meant is, hey, find the advertising because that's going to have the seller ID, which is linked to app user. Again, I find the picture really confusing. I just look at the code and it tells me everything I need to know. And a lot of the times this is what you end up doing in real code. You start looking for a keyword and you just do a command F and you search for advertisement or you search for app user, right? And then you just like click through it and you find it. In really big code bases, that's just what you do.
Are these tables given when you get the job?
No, it just depends if it's already a built application or you're building something from scratch. Most of the time they're already built and you're either refactoring, adding functionality, or sometimes, depending if it's what kind of application it is, just migrating it. But you need to know how it works, right? Like if you don't know how it works, you're never going to be able to fix it.
Yeah. It makes sense.
Yep. Great question, though. That was a really good question. Alrighty, boom. This is the image again. I'm not the biggest fan personally, but if this helps you, definitely do it. Once you have a path, this just goes through the path. Once you have the path from A to B, you can just kind of find their relationship. This is their answer. I think, wait, let me get their final answer here. This is their final answer. This is their final answer. Let's see. Yep. This is their final answer. I limited mine to 10. They didn't. What do you notice the difference between theirs and their answer and my answer, if you remember? They're actually the same answer. There's only, besides the limit, they're the same answer, except that the what is different.
The order of the columns.
Yeah, the order of the columns. Did I get the same answer though? Yeah. Right. The order of the column is, but that's just rearranging your SQL query. Notice they put count first. If you look at mine, I put city, make, and count. This order is different. But that's the only different. They I just order by city, but they do pay ascending order. This is actually excessive. You didn't need to do that. When you order by city the way that I did it, it default orders in that manner. So this you didn't need. But this is the way that they did it. And they start building the query the same way that I did. Their approach is a little different. I kind of like mine. But if you want to go through the README and try it again, you're more than welcome to do so. Here they do a good job of limiting it by one. We're going to get into your assignments here shortly, but let me just summarize here. Let me touch on these bullet points, make sure that they're important. To summarize, when faced with a complex query, trying to break it down into intermediate steps, I would actually pseudocode it, something like this in English. It doesn't have to be SQL. Also, I had to Google how to do some of this stuff because I couldn't remember, right? But I knew that my steps were right. I just have to find the right ones. Oh, and I don't know if you guys noticed, how do I exit the database in PSQL? Is it \Q? Yep, it's \Q. All right, cool. All right. I don't know if you guys noticed, but look at my SQL statements, 1 through 5. I just copied pasted them in order here. Did anyone notice that? I literally just rearranged them and put them in the right order, and boom. Got that. I posted it in the Slack channel so you guys can take a look. All right, so figure out which tables you're going to need to answer the question. Figure out how to connect those tables together if necessary. Write a query getting all the columns with some reasonable limit. That's really important. I typically just do one or two. Filter, aggregate one step at a time. Your challenges are going to be, I'm going to put this here at the bottom of this. Assignments. Boom. And we'll work together today. But before that, I wanted to show you your challenges are SQL School, and complete as many as the non-basic SQL problems you can with the remaining time frame, which I'm not going to give you that much time because I yap so much. And here's an optional challenge. And actually, the HackerRank ones are really good, but I would definitely focus on these two first. If you have extra time, hit the HackerRank one, but this is already kind of a lot of work, so I would just focus on these. But before I cut you loose and open the breakout rooms, let's look at this. Remember when I told you this is way too much data? Remember that? Why don't we load a database with just one element? How do we do that? Why don't we just restart our database in the Docker container with just one element or two elements? How would I go about doing that?
Just comment out the lines.
Okay, I can comment out the lines. Let's be very specific. Let's start at the bottom. And I mean, these are 1,700 lines, right? Let's see if we can do this very quickly here. Whoa. Comment out or?
Delete it.
All right, let's delete a bunch of this. Check. This is kind of a conceptual exercise here. Let's see if we can figure this out without spending too much time here. Oop. I am going to delete user profiles. I'm going to delete these user profiles. Boom.
You went too far up.
Did I? I think I did. This is another reason why I'm not a big fan of big data sets when you're learning how to do this. Alrighty. All right, we're gonna get this. Okay, these are advertisement values. Yes. Is this just one table? Damn, this is so much information. Okay. Boom. Okay. This is advertisement values. Yes. Cool. Now this one is who? Which table is this? Which table is this? You guys can look at your own.
You
I
jumped
think
into
you
the
went
next
too
one again.
far. Yeah, you went too far.
Did I? No way. Jesus. All right. I did. Okay. So this is, what table is this? All right, I'm going to pay attention more in my right hand screen here. Boom. I'm just going to do this. All right, that's right? Boom. All right, cool. Got this. Got this. All right, these are cars, it looks like, right? Boom. And what is this? These are what, people? All right, I have a smaller data set, right? Oh, that's super sloppy, but that's fine. All right, I have a much smaller data set, yes? Okay, cool. I want to load all this data. What do I do? Docker PS. That container running, does it have my update? I deleted a bunch of data. Does that container have that update?
No,
Why not?
because it's like a snapshot of something.
Yeah, it's a snapshot, but I've already loaded all that data in. I deleted all of my data where?
Locally on your machine.
Yeah, locally on my machine. Cool. But I really want just to load this little bit of data. So it's going to be easier when I go in here. I don't want a million things. I'm still learning. I just want this. All right, so what do I have to do? Think about this. This isn't in the README. I'm just think this is important.
Eliminating the last container and reopen it again. Maybe.
Okay. Yeah. All right. So what's the command? What do you want me to do first?
I will go to container and erase that from Docker, from the Docker itself, from the desk, and redo it all over again.
You want me to do, okay, give me a second. You want me to open Docker with the GUI, right?
Yeah, I would do it in that way. I don't know.
Okay. You can do it via the CLI, but we're going to do it your way. Yes, I can do it this way. This is a way to do it. I encourage you to use the CLI to get comfortable with it, but you got the right answer, so let's roll with this. I'm going to delete it here, yes?
Yep.
Boom. It's gone. I don't have any containers running. Awesome. Cool. I can go in here and I can go Docker PS. How many containers do I have running?
No,
None. Perfect. Now what?
no, I'll do the Docker build.
Docker build this command right here.
Yep.
Awesome. What's wrong? Anyone? What's wrong here?
You're not in the right directory.
Perfect. Now I'm in the right directory. Now I'm going to build that again, right? And this should work. It does. Perfect. Now what?
Docker run.
Docker run. Perfect. Docker PS.
Ooh,
What happened?
there's no there.
All right. Let's look at what was it? Let's run this command again. It was this one, right? Cool. That looks right. Now let's try this one. Docker run, right? Let's see. Okay. Docker PS. What's happening here?
There's no container.
Why not?
That's a good question.
I want you guys to do this. That's why I'm showing you this. Right? That's way too much data to deal with. I want you with this.
Are you logged into Docker?
Yeah.
That cause that?
Yeah, I'm in. No, the fact that I'm not logged in doesn't really matter. I had a Docker container running. Maybe delete all this. I don't know. Volumes, builds. I'm going to delete all this. All right. Builds. All right. Deleted everything. This should work. All right. Let's do build. That looks right. Yes? Now, can I literally just copy it straight from here? All right. That looks right.
Can I copy the first 6 numbers from the last one, from the Docker run? I think they match. I don't know if it worked. I'm just guessing.
What do you mean?
When you run the Docker run, you have a code, right?
No. No,
Code.
I'm just trying to start that container, right? There is no containers running.
Okay.
How would you go about debugging this?
I'd probably get mad and just recreate my directory, clone it down, then start over.
Okay. Let's not do that. All right. Let's do Docker images. What is that going to show us?
The images that you have created,
Yes. And the container launches from what?
the image.
Yeah, image, right? So Docker build. Okay. And I do Docker images, just rebuilt it again. So there is an image, right? Docker logs, Docker PS. I built that image 4 minutes ago, right? I should be able to run it. And it doesn't seem like I'm able to do it. All right. I've been yapping too much. I want you to run this exercise. I sent you the init SQL file. I just posted it on there like a Neanderthal. Grab it, replace the init SQL, and see if you can run it with just the limited data. Once you're done, run a couple SQL commands on it, make sure it works, and then you can get started on your assignment. If anyone figures it out, please post it in the Slack channel. Right? What I'm doing should work. Why should it work? What's the only thing that I'm trying to do?
You just
Run a
kind of
new
fill the
container.
columns.
Yeah, I destroyed the old container. You saw me, right? So I'm just building another image and trying to launch that container with a new data set that's much smaller. I should be able to do that, right? See if you can do it. Once you figure out how, post it in the channel. I am going to open just a small group of, if I can figure this out, breakout rooms. Feel free to pick your partner. I'm not going to assign you partners today. Pick any partner. If you need to take a break, definitely take a break. I'm going to let you pick your own rooms. Please work with someone. Rooms open. Definitely take like a 15-minute break. Come back at 8:16 and get started with your assignment. I'll jump around your breakout rooms, starting probably at like 8:20, 8:25. Alrighty. Let me pause. Does everyone understand that? Yes? All right. The most common mistake that I saw jumping into your rooms, and I don't really mean to call anybody out, is what do you think the most common mistake is when I jumped into a couple rooms? Just guess.
Where am I?
Yes, by far. That was actually the main mistake, right? You don't know where you are. And I keep harping on it. And I saw it at least 4 times just now. Not to call anybody out, but I'm just letting you know that's really, really important. And I mentioned it earlier because I knew it was going to happen. It happens every cohort. It's going to continue happening, right? So pay attention of where you are. Logan, if you didn't really understand the error that Logan and them ran into is we think that the file structure is wrong, right? So when they were trying to run a file that loads the database, it was in the path was wrong, right? So we believe that's what the issue was. But if you knew that, hey, I'm in this specific environment and the path to the file needs to be here, right? You would be able to figure it out. That's actually a really important concept. So keep that in mind. I will look at this at the end. You got the most important problem. What else did I see? Okay, I'll leave you with this. Focus on the question I'm about to ask you. Do you need a virtual environment if you're inside a Docker container?
No,
Why not?
because all the environments are in Docker.
That's not the right explanation. If you want to try again, I think you know it, but you can't explain it.
I just know that Docker is the go around to having to create a virtual environment so we can launch it. So it should be everything that we need would be loaded in the Docker file. Something like that.
You're kind of saying it in a really awkward way. Someone explain to me
Yeah,
why
yeah.
I don't need a virtual environment in my Docker container.
Isn't the Docker container a virtual environment in itself?
Yes. The Docker container is already an isolated environment. There's no need for a virtual environment. Yeah, if I had a virtual environment inside of a Docker container, inside of VM, how many environments is that?
Two?
If I have a virtual environment inside a Docker container, inside a virtual machine, how many environments is that? It's not two.
There's 4 if you also count your local machine that it's
I'm not.
inside
I'm not.
of.
I'm not
So
counting
then
my
it's
local machine. So
then it's
it's
just 3.
yes, super, super, super important, right? The concept of Docker here is very, very important. Make sense?
Wait, how is 1 + 1 = 3? Explain me that, please, Guillermo.
A virtual environment is an isolated environment for an application. But if that's also in a Docker container, that in itself is an isolated environment from your local machine, right? But if it's on your local machine, that's 3 layers, right? So you can be on your local machine, you can be inside the Docker container, but you can also be inside your virtual environment. Or as we saw it in this case, you can also be inside your database, inside of your Docker container. It depends at which layer you're working. Make sense?
So if I'm working locally, it will be choose the virtual environment.
Yeah, it just depends what you're doing.
Okay.
If I'm playing around with a bunch of dependencies and I'm doing it locally and I'm using Python, yeah, virtual environment's probably the best bet. That didn't all make sense to you right now. That's okay, but it's something that I want you to keep in mind going forward. Because one of the biggest problems that we have when we start Dockerizing things is understanding why they can't talk to each other. Any last minute questions, guys, about SQL queries? There are no questions. I actually have one last thing. Sorry, one last thing. Just gonna pull this up real quick. I meant to do this earlier and I totally spaced. Can everyone see my screen? Okay. Last thing, I promise. I know I always say last thing. All right. What command is this? What kind of command is this on line 5?
Secret command.
Yeah. If I wanted to do this manually, at which layer would I run it?
Sorry, layer, or you mean like environment or layer?
Okay, I'm going to ask that question again. This is a real command. When you populate your database in this exercise, right? It's just executing this entire file and it's populating it with all this data. Yes?
Yeah.
You can run these commands manually and you can insert this data manually. But if you have 1,000 elements, how long is that going to take? A long time, right? So these are real commands, right? So based on the cards database exercises that we did today, I can run this command at which layer?
Oh, at the database layer.
Yes, Jose. You're quickly rising up the ranks of this class, Jose. Nice job. Did everyone understand why?
Because that's the only place those commands work. It doesn't work
Yeah,
when
I
you
mean,
regular machine. It only works in the database.
it's a database command, right? And database commands only work within the database, right? Bash commands only work within the bash terminal. Yes? Does that make sense? I don't know if anyone really broke that down, that init file, right? That's just a file that they use to populate data in a database very quickly. But every single one of those commands, you can run them manually. Here's an exercise if you don't already have a million things to do. Create a database right, of like cars or pets or whatever, it doesn't matter, and add a pet manually. Insert, run that command manually, and add another table, right? Add a primary key, add all that manually. And you'll see that you can do all that one line at a time. Is it going to take forever? Yes. That's why they use scripts that just manually load everything, right? But that loading it and running that command with that -f init.sql command, go look at that command. That's just saying, hey, when you start this container from this image, load all of this data or execute this script that loads all of this data. Make sense?
Oh, okay. So let me get it. So when you go when you do it from a SQL, you do it manually, that you're saying it. You create the database, right? Then you create the tables, right? But you only have to do it once. Then let's say you messed up on the table, you have to put delete table and then redo it again, right?
I don't think
So
you
this,
delete table. I think you drop table, but yes.
oh, you dropped it. You dropped it. That's right. So we could do it. We could do the same thing, but in Visual Studio. Is that what you mean? We could do it one by one.
You can do it in the terminal one by one. Yes. You don't have to run the fancy script. Running the fancy script actually abstracts what's happening, right? Did they have you guys load information one by
Yeah,
one?
I had to do the fancy script since you corrected at the last minute, so I had to do the whole. I
No,
mean,
but did they teach you to add users manually?
yeah,
Okay.
yeah, but in the SQL app,
We don't
like
have
there's
an SQL app.
no here, but I did it before.
Okay. If you haven't done that exercise or we didn't teach it, it's a good exercise. Remember how you created this school database table? Create a table manually and insert things manually, right? And then take all those commands that you use and write a little init SQL file and then put them in the file and then do it both ways. One of them abstracts what's happening. The other one, you have to do it manually. One's obviously a lot faster and a lot better, right? But if you don't know how to read those commands, you don't know that they're just regular, SQL commands. Does everyone understand that? That's actually really important, right? Yes? Cool. Uh, Last thing. All right, for real, last thing. All right. Eventually, you know how you run your commands? You say docker exec, docker build. Remember those commands? Yes, everyone? You need to know that, right? Eventually, when you look at a real application, they're just going to have start scripts. You're not going to start it like that. It's a pain in the ass. So you're going to have something like start.sh or something, and then all of these commands, right? What was the other one? Exec, Docker, run or whatever. I'm just using these two as example, right? But you're just going to have a bunch of this, right? And then you're going to have like a start script, right? So when you clone an application, they're like, hey, start it up, right? You're just going to do something like what? Anyone can finish this? You're just going to run one script. Which is it going to be?
./startup.sh.
Yep.
And you may have to make that executable too.
Yeah, I'm not going to go into that, right? You see my terminal highlights in red because it's not executable. I'm not going to change the, I suppose I could. I could change the permissions on that script, which I did. Now I can execute it. Well, I guess I have a lot of scripts. There you go. Now you can see it turn to green because now it has the permission for me to execute it, right? But then you run something like this and it will just run all this abstracted code to start my application, right? Eventually, right now you're learning how to do it manually, but eventually this will just run a startup script, right? That says, hey, build the image, hey, run the container, right? It might have another code in here saying, hey, check if a container is already running. If it is, destroy it. clean everything, and start new container. Right? Right now, if I wanted to delete a container, how would I do it?
You remove the name. It's probably the easiest. So do
I
or
could.
that's the image right now. I think is what we. Okay, no, the container.
This is
You
my
do like
container, right? I could use the GUI, or I could punch in the CLI command to destroy the container, right?
that. that.
Right. But eventually, you'll just draft something like this, run that script every single time. If there's already running, destroy it, run everything else, run all my commands, and then I don't have to put them in one by one, right?
What's the command?
For this
Hmm.
is just an example, but you just run the start script.
To delete the container?
To do whatever you want. The start script can do whatever you want. Right. I'm just showing you an example of eventually what this will look like. Right. Kind of comparing it to this. All these are commands that you can run by themselves, right? When you run the container, it just runs a script and it populates all of this data. But all of this can be done manually. This script is actually an abstraction of what's happening. But you need to understand what all this is doing, right? Because eventually you get another layer of abstraction, something like a start script, right? Where you're not no longer punching in just single Docker commands. You're just running a script and then it's doing everything for you. And every single one of these layers, right? It's just another layer of abstraction. It makes life easier, but if you don't know what's happening under the hood, then it's hard to kind of debug it or build it. I hope that made sense. Yes?
Awesome.
Yeah. So this init script, guys, you actually could still run the exact same exercise and delete this init SQL. The only thing that would change is you would input all the data what?
Manually.
Manually. That's it. You actually don't need that init one. It's just a nice to have, right? All right, I just blasted you the last 10 minutes. Sorry about that, but I just wanted to show you kind of where it all goes. Hopefully it provides a little bit of context. There you go. Thank you, Justin. Docker RM. You remove the container, you can remove the images, all that good stuff. Or you can eventually have just a script that does it all for you. Awesome. I will look at the school assignment right now and I'll make sure it works and then I'll post the answer in the Slack channel. Okay.